Hi, this is a paper on enhancing creativity and technical competence for design students using virtual reality tools. It's a paper by myself, Mehran Koohgilani, and my colleague Richard Glithro. We are at Boms University, and Richard works in the Innovation Center, and I am an academic in the design engineering department. The paper essentially is very important as it is basically capitalizes on the students who are this generation of students who are savvy with technology or should be savvy. These are the generation which grew up with mobile phones, tablets, and laptops. So, and internet and social media and all the wonderful things that these guys are familiar with. I don't like to talk too much on this paper because number one, the paper is an observation. This was a case study which aimed to see how useful virtual reality would be initially. Virtual reality, as far as the current generation is concerned, is what they've seen on movies, or if they've been lucky to basically go into arcade games, or have had things like the PlayStation VR set, or at the lower end have used things like the Gear VR of the phones like Samsung Galaxy series. However, this is those are a different world. We are looking at how we can enhance the engineering and design skills of students, especially when they join us at 18, and many of them have had no experience in the workshop or in manufacturing at all. So what the aim was essentially to look at how we are would be useful, and look at the pitfalls that it could generate, and then learn from those and essentially implement them in the future works that currently is being implemented. What drove the project? We know that there's a large gap between what is taught and what is expected from students when they go from schools and universities. And with the advent of the fees, and I'm sure all of you are familiar with all the problems that we have faced in the recent years when we moved from grant-based to a student loan, and the expectation that was changed from the students' perspectives. Of course, there is the commercialization pressures, both by industry, because industry wants these guys to come and be ready to engage with the industry without having to retrain them, as well as the same commercial pressures on universities, because the universities need to generate income. These income models are also what drives some of the work that the universities do, because at the end of the day, funding is reduced, and we need to make money. So we had to look at essentially the available technologies, and the essentially the pedagogies that we were going to implement. So that balance had to be looked at very carefully, because after all, there are guidelines, there are checks and balances, and we needed to make sure that every I is dotted and every T is crossed. Why virtual reality? First and foremost, let me start by saying that because I like virtual reality and I find it fun, and I basically like it, but the other main reasons were the availability of the technology. We did have the kit at university. We have the expertise within the technology, and effectively the potential that exists in virtual reality. I mean, I do not want to go at the tangent of this, but we are looking at virtual reality in everything implemented from implementing it within civil engineering to design management to project management to even teaching with it as a part of a group meetings, and obviously just like everything else, technology has its shortfalls, and it will always be difficult, have difficulties, but that's the fun of research. The potential that we saw in this was very encouraging because the students enjoyed working with it. What was the case study? We chose an existing undergraduate workshop scale project, which was used as the foundation for the VR experience. They were required to manufacture and assemble a simple oscillating engine from engineering drawings and operation sheets. This can be seen in the slide, in the next slide. The key was that we knew that many of them had never done any manufacturing. We knew many of them had possibly never even had done 2D drawing, let alone 3D drawing or assembly drawings. And so this was, from previous experience, was shown that a lot of work was done initially just to make the students understand what was the drawing was about and what was required from them. So virtual reality was going to be used as a tool, a visualization tool, to help them understand the basically the drawing and the task at hand. Mentioned here is the slide with the engineering drawing on it, and you can see the actual product on the next slide, on the which was made originally by a previous cohort. As you can see from the engineering drawing, it has very close tolerances, and it's very important that for somebody who has never been in the workshop, has never done any assembly, to understand just the drawing, it would have been a daunting task. This was the use of VR was also going to be a case of saving time in the workshop and removing that initial fear factor. As I mentioned, we called on our experiences from dealing with the students with this project and previous projects in the past, realizing that the difficulties that they had in interpreting the engineering drawings. So we introduced a VR. This was used in order to provide a scale-up virtualization of the assembly for them to be able to see how the sections go together. This was not something that they developed, this was developed for them. However, they did interact with it, which is the main aim of this project initially. I've already said why we were using VR and how, but essentially it was in 3 sections. An assembled version of the oscillating engine was available. all the components were also laid out for them, so they could actually see each component and associate with the engineering drawing and assembly, and an animated, most importantly, an animated version of the exploded assembly was produced. This was the key, that they could see how the components will go together. A screenshot of the uh, essentially the animated version is shown in the next slide, but the key is that we were relying on them seeing the product. So I think about it this way. They basically now could actually see how it goes together. Is many of them, these guys would not be able to put a flat back together much a lot, and the drawings will be very confusing for many of them, because after all, of the generation that they are and how they've grown up and how things have been essentially presented to them. So this was the key that we were building on. The animated exploded view, which was the key here. Students were given access to VR at the same time as when they started looking at the physical manufacture, and they were going to the workshop. Now, they spent about 5 minutes watching the animation and having the VR set on. The key is, why 5 minutes? Why not more? There are a few factors here. One is the fact that the sheer number of them and the physical resources that we have, we could not supply one VR set to every student, as well as the fact that we also did not want VR to basically be the only medium that these guys are going to be working. After all, the plan was that they were going to make it so the VR was just a tool to enable them to visualize the component and be able to go in. Again, the question would have been, why simply not just show them the animation? It was more about the immersiveness of it and them to be able to actually move around the animation, move around the product as you would in a VR world, whereas in animation means that the animation has to be rotated and you will have to do it using a mouse or have it on a timer to do it itself. This was supposed to be a more interactive way for them. Well, this was an interesting observation that, as I said, VR is what I'm passionate about, what I like, but it was also interesting to watch these students essentially go through this. As you expect, just like every subject, just like in every area, there are engagement varied. We had some who just basically put the headset on and that's it. They would not be able to actually engage with, or had lack of engagement, or due to various reasons, which is outside the scope of this paper. However, we have looked at that in another paper. But the ones who did engage, the ones who actually found it useful, it was they engaged with it very well. It was interesting to see, standing outside, watching their essentially body language as they basically moved around the components, and they even crouch to actually or bend over to look into various components, which was again a subject of another research that we are doing, and it was very enlightening to see how this new generation of students are actually taking to a technology which should be right up where they are. And after all, they've seen this technology in movies, they've played games with them, and you can't go to a high street where there isn't a shop trying to entice you to get into the virtual reality world as a game. And the technology has gone leaps and bounds with this compared to only a few years ago. I mentioned this was essentially a case of students interacting with it, and we made observations, and this was the first time that we were trying to implement this. We really were going to use this as a pilot case study to build the future work on. So the observations that we made was done more in a way of talking to students and listening to them and finding out essentially more directly there and then about their experiences, rather than waiting and then giving them a feedback sheet and then getting them to fill these. So we wanted an instantaneous feedback of how they found this. So, and overall, as we expected, the feedback was very positive. I mean, who wouldn't be happy to don a few £100 worth of equipment on and actually get a chance to play with the latest technology? And so they were very positive, and they found the actual scaled up model and the animation very, very useful. As I said, many of them had never actually assembled anything, gone the days of even Lego or Meccano sets that many of us grew up with. These guys had possibly hadn't played with. The closest they came to playing with any of these games may have been through an app, actually doing it on an app, but never actually making anything. So the concept of going from the engineering drawing to the final product and seeing that process in animation was very useful for them, and they actually enjoyed it, and they were asking for more, and they wanted it to be implemented in their future projects, which we are, as I said, as part of the bigger picture we are doing now. Expected, students found it easier to understand the relationship between the different components and how they assemble together, how they fit together, a lot more confidently using the system, the VR system that we basically implemented. It would have been a real disappointment if it didn't actually turn out to be positive, because that was the key. We knew this is one of those things that you had a gut feeling that this would be a positive outcome. However, we always, as they say, you hope for the best and you essentially prepare for the worst. So we had contingency plans that if it didn't work, what else we could implement given the time frame that we had to implement the system in. So we were very happy once we found that majority of the students uh, actually found this to be a very positive aid to their understanding of how the whole process works. It goes without saying that VR, virtual reality, has great potentials. I mean, uh, it has been used in everything from medical to gaming. So, and Hollywood has been pushing the boundaries, albeit through CGI and not through VR, but uh, they've opened up the potentials that exist. So, but we also knew that it has a great potential to be integrated within design process and be able to bridge that gap. And our observations of the students and the exercise prove this to be a valuable tool. The ability to be able to actually scale up models and be able to highlight various components is a valuable experience that students learned. And as I said, we have several pilot projects which are looking at various aspects of this, and students are asking for more. And of course, we are now looking at the augmented reality as well as essentially human machine interface with this. So there are potentials that uh, came on the back of this, but fundamentally the observations, our final observations was that students wanted more, and it was a resounding success as far as we were concerned, and a lot of fun on at least my half. So, what is for future? First and foremost, I want more of these toys and more time to play with them. But on a more serious note, we want to be able to actually fully immerse the students in the virtual medium. Uh, give them more time, give them more freedom, give them chance to actually explore these ideas more, develop more projects, uh, make them uh, participants and makers of the actual process rather than just being mere observers or mere users. Uh, it's that immersive experience which is important, and we want to make sure that we develop this into more wider field of design and engineering, and even given the opportunity, take it even further to within other areas, uh, even as far as going into humanities. However, from a design engineering point of view, we do not want this to impact their dextral and cognitive abilities, because in a previous work where we looked at the how rapid prototyping was used by the students and how it was used to improve their manufacturing skills, our findings showed that they enjoyed rapid prototyping and 3D printing, but the that came at the expense of their creativity and their design skills and design process. So we don't want the tools that becomes available to them actually be detrimental to their abilities to make useful and creative and innovative products. And thank you very much, and I hope that you are feeling the joy that I am feeling with this toys and these products and this process and this technology.